Let's look at how to prove the cosine rule. Trigonometry, 2 and 3 dimensions. How to prove the cosine rule. Given triangle ABC, in which angle C is bigger than 90 degrees, prove that C squared is equal to A squared plus B squared minus 2AB cos C. Angle C is bigger than 90 degrees means the triangle is an obtuse angled triangle. Now, to do the proof, we start by doing some construction. We have to indicate the height of the triangle. If a triangle is obtuse angled, the height of the triangle, we can indicate the height outside the triangle. So draw a perpendicular height of the triangle and label it. So in my diagram here, it is line AD. I'm going to label that one H. This construction has created an extra line from point C to point D, and that part, I'm going to label that one X. You can label it anything of your choice. Our construction is complete. We can now go ahead and do the proof. The proof is done using the theorem of Pythagoras. We know that the theorem of Pythagoras is applicable in a right-angled triangle. And we do have two right-angled triangles here. So we're going to apply the theorem of Pythagoras in those two right-angled triangles. Let's start with triangle A, B, D. In triangle ABD, we know that the hypotenuse is AB, therefore AB squared is equal to AD squared plus BD squared. This is an expression that we are getting from the theorem of Pythagoras. Then in place of AB, we have C, so that will now become C squared. In place of AD, that's H, so that will be H squared. Then in place of BD, BD is made up of A plus X. So it's going to be A plus X and then squared. This will need us to simplify it using the FOIL method because it is a binomial. So from there we simplify the expression. A plus X squared basically means A plus X factor of A plus X. Then we expand these brackets using the FOIL method. So then simplifying, this is H squared. Using the FOIL method here, it's going to give us A squared plus 2AX plus X squared. We have simplified this expression. This is the value of C squared. So we can label this one as our first equation using the theorem of Pythagoras. Then after that, you go to the next available right-angled triangle, which is triangle ACD. In triangle ACD, AC squared is equal to AD squared plus CD squared. This is also coming from the theorem of Pythagoras. AC squared, that is now B squared, because AC is equal to B. A to D is H, so that will be H squared, and CD is equal to X, that will be X squared. We have done this using the theorem of Pythagoras. Now, this will give us equation number 2. To finalize your answer, you integrate the first equation and the second equation. Basically, we're going to substitute. If you look at our first equation, our second equation, B squared is equal to H squared plus x squared. And in the previous statement, we have c squared is equal to h squared plus a squared plus 2ax plus x squared. So there is h squared and x squared in equation 1. So what we do now is that we go back to equation 1 and say, therefore, c squared is equal to, in our previous equation, we take out h squared and x squared and replace both of them with b squared, because we know that b squared alone is equal to h squared plus x squared. So in equation 1, we're going to remove h squared and x squared and replace both of them with b squared. Our first equation now becomes c squared is equal to a squared plus b squared plus 2ax. That is now how our equation looks like after substituting h squared and x squared with b squared. Our next task is to remove x from our equation so that our formula may be complete. To do that, we go back to triangle ACD. In triangle ACD, in triangle ACD, if you look at the triangle ACD, we're going to notice that it is a right-angled triangle. In a right-angled triangle, we can apply the theorem of Pythagoras, we can apply trigonometric ratios. So in this triangle, we use trigonometric ratios to express the value of x. Now, if you look at the triangle at point C, there are two angles there. One angle is angle C from triangle ABC. Then the adjacent angle there is 180 degrees minus angle C. Using the idea of angles on a straight line, they add up to 180. So in triangle ACD, the cos of that angle, the cos of angle 180 minus C, the cosine of any angle is equal to adjacent. Our adjacent is x divided by the hypotenuse. The hypotenuse is b. Then from there, we cross multiply. 1 times x is equal to b multiplied by the cos of 180 minus c. Then using reduction formulas, the cos of 180 minus c is the same as negative cos c. So this changes this expression into minus b multiplied by the cos of c. Then we go back to our equation and say, therefore, the value of c squared is equal to a squared plus b squared, then plus 2ax. And in place of x, we're going to substitute with minus b times cos c, because x is equal to negative b cos c. Then if you simplify that, you get c squared is equal to a squared plus b squared. Then this positive will now become negative minus 2ab multiplied by the cos of c. And that completes the proof for the cosine rule in an acute angled triangle. So very much important to know how to do this. You don't have to memorize it because the steps are very clear. You just need to study. So quick one, how did we start our proof? We draw a perpendicular height outside the triangle and label it H. And then we also label the other line that we have produced from BC to D as X. Then using the theorem of Pythagoras, we express the value of c squared using the theorem of Pythagoras we have c squared is equal to h squared plus a plus x squared. This part here, these brackets, we need to remember that if you are multiplying a binomial a plus x squared, then it becomes a plus x factor of a plus x. So this one is then simplified using the Fourier method. That's how we got this part simplified. Then after that, you go to the next triangle, which is now triangle ACD, and you do the same thing. You express the theorem of Pythagoras there, and once you do that, we notice that b squared is equal to h squared plus c squared. So b squared alone is equivalent to h squared plus h squared plus x squared. So it allows you to go back to the previous equation. In the previous equation, we're going to remove h squared and x squared and replace both of them with b squared. So that's how we got the b squared in. So b squared is replacing h squared and x squared combined. Your equation now becomes c squared is equal to a squared plus b squared plus 2ax. Then we need to get rid of this x. So this x is coming from our triangle after doing some construction. This is where x is. So in triangle ACD, we notice that that x there is the adjacent of the triangle, and the side B is the hypotenuse of the triangle. Then adjacent and hypotenuse means we can apply the cosine of that angle. So we need the cosine of this angle here. The angle that we have in the triangle is C. So then the other triangle must be 180 minus C, because angles in a triangle, they add up to 180. So the cos of 180 minus C is equal to adjacent, which is x, over hypotenuse, which is B. Then we cross multiply to get x is equal to B times the cos of 180 minus C. Then we use the reduction formulas to reduce 180 minus c, cos 180 minus c, to negative cos c. Then we bring the value of x, which is minus b cos c, into the value of x in our equation. So that will then give us the simplified answer for the proof of the cosine rule. In that way, the cosine rule has been proved.